Good morning and welcome back to my elective mathematics class. I am Rashid Adomako, Pukuwaru School, and this indices SHS 1. From our previous meeting, we looked at the definition for indices. Then we also looked at the laws and properties of indices. Now, you said that the index notation is a simple way for writing repeated factors. So you said that when we have a number like a times a times a times a, there is written as a, then we count the number of a's, which is 1 2 3 4, so we bring it as an exponent over here. So now there is the index notation, and then this is the repeated product. So this is what we talked about in our previous meeting. Then we also looked at the rules and the properties of indices. So we have all the rules here. I was able to prove all the rules and the properties during our first meeting. So let's quickly go over the rules and the properties so that from there you will solve questions based on the rules and properties. Now the first one, we have what we call the product rule. So when we have two numbers of the same base being multiplied, their exponent or indices are added. So we call this the product rule. Then we also have the second one, where two numbers of the same base are divided. Their exponents are also subtracted, as we have over here. So there is the quotient rule. Now we have the exponent of exponents. Now there are three types of them. The first one is when we have a number in index form, raised one exponent. Now their exponents are multiplied, as we have over here. Then the second one is the power of a product. We have these two numbers multiplying. They are all raised to a certain exponent. So it means that we take the a exponent m, then multiply the m by the x over here. Then we take the b exponent and multiply by the x over here. Now the other one is power of a quotient. Now when we have a over b or exponent m, now it's going to give us a exponent m as we have over here, then b exponent m as we have over here. So these were the rules that we talked about in our previous meeting. Now for the properties, we have the zero index. We said that any number except 0 raised to an exponent of 0 is 1. So 10 raised to the power of 0 is 1, 100 raised to the power of 0 is 1. But then 0 raised to an exponent of 0 is an indeterminate form. Okay, then we have the negative index. We said that when we have a raised to the power of negative m, then we find the reciprocal of it, that is 1 over then this number, neglecting the negative. Then we also have an aspect of it where we have a over b all raised to the power of negative 1. So now we find the reciprocal or we turn it, then we get b over a. Then an aspect of it is when we have a over b raised to the power of negative m. This will give us b exponent m over a exponent m. Then we look at the last one, which we call the fractional index. Now you said the fractional index is a root. Let's look at how it is. When we write a raised to the power m over n, this is the root. Then this is what we call the exponent or the index. So anytime you see a fractional exponent, then we are to know that it is a root. Okay, now this is written as the root is n, so we write the n root. Then we bring the a here. Now the m is the exponent. So this is how you write a fractional index. Okay, so with all these said, let's look at some questions using these rules and properties. Now question set 1. Okay, so we have these questions here. Now, question 1. Write each of the following in radical form. When we talk about radical form, it means that we are writing it in the form of a root. So the radical sign is this symbol. So we are now to write each of the following using the radical sign. But then we shouldn't forget that we have stated earlier that a fractional index is always a root. Okay, so let's look at how we solve these questions. We are using this idea. Now we said that this is the root, so the root comes here. Now the a becomes the radicand. Then we bring our bracket here. The m here becomes our exponent. So we are going to use this idea. So a, we have been given a raised to the power of 3 on 5. Now the denominator for the fractional part is 5. So we write this as the 5th root, so it comes here. Because it's the denominator, so it comes here. Then the radicand becomes a. We bring our brackets, then the exponent is 3. So this is how we write this in a radical form. Now the second question, B. Now this question is in two parts. We have a fractional index, but then it is negative. So you need to deal with the negative first, using what we call the negative index, as we have over here. So straight away, we need to write this as 1 over the whole expression here, so that the negative sign will be done away with it. So we write this as 10, then we have 3 on 2. Then we have to write this as a radical. So now we can write this as 1 over. Now the denominator is 2, but then this symbol is known as the square root. So it takes away the 2. So you can write this as 10r. Then the exponent is 3. So this is how question B is solved. Now C. For question C, I'll give you 15 seconds to solve question C for me. So your time starts now. Okay, so now let's compare answers. So now we have this as a fractional index. The 3 is our denominator, so it means that this is the same as the cube root. So we bring the 3 inside. Now this becomes our radicand, which is 7x. Now this 2 is our exponent, so we bring the 2 here. I hope you had this answer. Now let's look at the last part, which is the D. So for the D, I'll leave the D for you as an assignment. For our next meeting, then you look at it. But then use the same idea as we did for the B to solve for the D. Okay, so there is question set 1. Let's move on to question set 2. Okay, so we have question set 2 on the board. Okay, so question set 2, we are to write each expression in exponential form. So what this means is we are to write it so that we have the number as, let's say, v raised to the power of 3 or so. So let's start with the first one, solution. Now A, you have been given 1 over the square root of 6x, then raised to an exponent of 3 here. So now we ask ourselves, what number is here? So you know that the number is 2. So we can write this as 1 over now 6x. The number here is 2, so it becomes the denominator. So let's write the 2 here. The number here is 2. Then we bring the exponent here, which is 3. Then we can use the negative index property to continue. So you can write this as 6x exponent negative 3 on 2. So this is our solution. Now let's look at question B. Now let's start from the denominator. So now the number here is 3, so it becomes 2 over 3, our exponent. So you can write this as 6 over 5x, then we have 2 over 3. Because the exponent is 2, the number here is also 3. Then from negative index, we can send this number here so that we have 6 times, then we have 5x exponent 2 on 3. Let me write my x well. So we have it this way. So you can therefore state that 6 on the cube root of 5x all squared is the same as 6 times 5x exponent negative 2 on 3. Then number C, you have the square root of v. Now let's don't forget, this expression is the same as so now we have v, then 1 over the number here, which is 2. So you can therefore state that the square root of v is the same as v raised to the power of 1 over 2. So there is question set 2. We are moving on to question set 3. Now there is question set 3. So we have to evaluate the following. A. 81 over 256 exponent 3 on 4. Then B. 25 over 49 exponent negative 1 on 2. Then C. 100 exponents 1 whole number 1 on 2. Then D. 0.027 exponent 2 on 3. Okay, so let's quickly go through these questions. So A, we have 81 over 256 exponent 3 on 4. Then we use property 3, the II, rule 3, the II, where we have the power of a quotient. So when we have A over B exponent M, it's giving us A exponent M dividing B exponent M. So we are using that property that rule to solve this question. So we write this as 81 exponent 3 on 4 over 256 exponent 3 on 4. Now from fractional index, we said that a fractional index is a root. Now the denominator at the index becomes the root. So we are going to write the 81 as the fourth root of 81 because we have a 4 here. Then we bring the 81. The exponent here is 3. Divided by the fourth root because the denominator is 4. Then we have 256 all raised to the power of 3. Now what does this mean? When we write the fourth root of 81, now it means that we need a number. Now that particular number multiplies itself 4 times because the number here is 4 to get 81. So which number multiplies itself 4 times to get 81? You know that 3 times 3 times 3 times 3 will give us 81. So it means that the fourth root of 81 is 3. Then we have a cube here over. Now the fourth root of 256. So we want a number which multiplies itself 4 times to give us 256. So let's see. 4 times 4 times 4 times 4. So 4 times 4 is 16. Times 4 we have 64. Then times 4. Then we get 256. So it means that when 4 multiplies itself 4 times, we get 256. So the fourth root of 256 is 4. Then we have a cube here. So now you can simplify this. So 3 raised to the power of 3 is 3 times 3 times 3, which is 27 over. Then 4 times 4 times 4 is also 64. So 81 over 256, all raised to the power of 3 on 4 is the same as 27 over 64. Okay, now let's move on to question B. Now question B, we have 25 over 49 exponent negative 1 on 2. So the first thing we need to do is to take the negative out. So we are using this property. So now you can write this as 49 over 25 or exponent 1 over 2. Now we are using the third rule, which we have over here. That is the power of a quotient. So you can write this as 49 exponent half over 25 exponent half. So now let's continue. Let me rewrite the 49 exponent half here over 25 exponent half. Now there's a fractional index. And you know that a fractional index is a root. So we write the square root of 49 over the square root of 25. Now the square root of 49 means we want a number which multiplies itself to give 49. You know that 7 times 7 will give us 49. You can write this as 7 over. Now 5 times 5 will also give us 25. So the square root of 25 is 5. So you can therefore state that 25 over 49 or exponent negative 1 on 2 is 7 over 5. Okay, let's look at example C. 100 exponent 1 whole number 1 on 2. So for this question, I'm giving you 15 seconds to solve this question for me. Your time starts now. About 15 seconds. Okay, so your time is up. Let's look at the solution. Now the exponent here is a type of a fraction which we call a mixed number. Normally we refer to it as a mixed fraction. So we have a mixed number here. So we need to convert this from mixed number to an improper fraction. So how do we convert? The denominator times the whole number here. So they spread one whole number 1 on 2. So the denominator here multiplying the whole number part. So 2 times 1 will give us 2 plus 1. Then we get 3. So this expression is written as 100 exponent 3 on 2. So this is the same as fractional index, which is a root. Now the denominator is 2. So you write it without the 2 here. Then we have our 100. The exponent is 3. So the square root of 100 is a number which multiplies itself 2 times to give us 100. So we have 10, then the exponent 3, we get 1000. Then let's look at our last question, which is the D. So you have 10 seconds to solve this question for me, the D. Okay. Okay, so let's look at the resolution. Now this is in decimal, so we need to convert this from a decimal to a fraction form. So you can write this as 27. Okay, so you have 1, 2, 3. So 27 over. Now you move 3 places, so the denominator is 1000. Then exponent 2 on 3. Now with this said, we know that the exponent is a fraction. So we use the idea of a fractional index. We can write this as 27 2 on 3, then 1000 2 on 3. So we used the power of a quotient rule as we have over here. Then we simplify this as the cube root of 27 all squared over the cube root of 1000 all squared. Now which number multiplies itself 3 times to give 27? So we know that 3 times 3 times 3 will give us 27. So it means that the cube root of 27 is 3. Then we bring an exponent of 2. Now the cube root of 1000, the number which multiplies itself 3 times. It is 3 times because we have a 3 here to give us 1000. So 10 times 10 times 10 then we get 1000. So we have 10 here. Then exponent 2. Now 3 squared is 3 times 3, so we get 9. Then 10 squared is 100. Now let's not forget, our person was given to us in a decimal form, so we need to convert our answer to a fraction, a decimal form rather. So we write this as 1 2 1 2. So we have 0.09 as our final answer. So now let's take this assignment. So assignment. Okay, so we have this negative. We have these 4 questions as our assignment. So we can solve these questions. Then we present our answers for during my next meeting. Okay, so thank you and have a nice time.